This is Jay, your tutor for computer networks. In the last session, we have discussed what is computer networks and its different types. We have seen that the network can be categorized into three types based on size, based on structure, and based on type of an individual device. Based on size, we have seen that there is LAN, MAN, and WAN. Based on structure, we have seen different topologies, and based on type of an individual device, we have seen the client server network and peer-to-peer network. We are continuing our learning for computer networks, and today we are going to see the OSI layer and the responsibility of different layers. So let's start. So what is OSI layer? In the network, there are many types of devices are connected together. There are laptops, there are phones, there are tablets, and each device are working on different operating system. For example, laptop could be working on Windows, Mac OS, or Linux. Phones can be working on Android and iOS, and tablets have different operating system too. So if devices are working on different operating system, the representation of data will be different. And if you want to communicate two devices which are following different representation for data, there is possibility that one device might fail to understand what other device trying to send. So that is why all the devices should follow same protocol, which is called the OSI model. OSI model is necessary if you want to make one device communicate over the internet, and it is a collection of different protocols. The OSI stands for Open System Interconnection, and it was developed by International Organization of Standardization. You can see in the figure, this is the actually OSI model. There are total 7 layers. The first is physical layer, which is at bottom. After that, there is link layer, network layer, transport layer, session layer, presentation layer, and the application layer. And each layer will have some set of protocols. So let's see the brief working of OSI layer. As you can see in the figure, the computer is sending data, and when computer is sending data, the data will pass through all the layers. So you can see that there is application layer, presentation layer, session, transport, network, data link, and physical layer. And when device is sending data, the data will be passed through all the layers. So data will be entered to application layer. You can see the original data is D7 and the header H7 is added at application layer. After that, H7 and D7 will be encapsulated at presentation layer, and H6 header will be added. After that, H6 and D6 will be together considered as data, and when it is passed to session layer, it will encapsulated and header H5 will be added. So when data is passed, each and every layer will add some data, and after that data will be sent. Same procedure will be followed at receiver side too. So when the receiver is receiving data, the data will also follow through all the layers, but the direction of the layers will be changed. Notice when sender is sending data, the data is following from application layer to physical layer. But when the receiver is receiving data, the data will be passed from the physical layer to application layer. So at the physical layer, data will be received and header will be removed by each layer. Notice that the header which is added at particular layer at sending side, that header will be removed at that particular layer only. For example, at the sending side, the H7 is added at application layer. So at the receiving side, the H7 will be received at application layer only. No other layer can remove that header. Let's see the animation so you can have the clear idea. You can see When data is sent, it will pass from top layer to bottom layer, and it will send through all the networks to the receiver. And when the receiver receives data, data will follow from the physical layer to application layer. So the direction of data is changed, right? Let's see the working of each layer in brief. The first layer and the lower layer is physical layer. Let's discuss the responsibility of physical layer. The first responsibility is physical characteristic of interface and media, then representation of bits, data rate, synchronization, transmission mode, line configuration, and physical topology. Let's discuss all. Now let's discuss responsibility of physical layer in detail. The first responsibility is physical characteristic of transmission. The first characteristic. Let's discuss. Let's discuss the responsibility of physical layer. Let's discuss responsibility of physical layer in detail. Let's discuss responsibility of physical layer in detail. The first responsibility was physical characteristic of interfaces and media. So the media can be wired or wireless. If it is wired, then there are different options available. It could be coaxial cable, it could be optical fiber, it could be twisted pair cable. If the communication is wireless, then it could be radio wave, it could be Bluetooth communication, etc. The second responsibility is representation of bits. What is the meaning of representation of bits? When two devices are communicating with each other, the representation of bits should be same. For example, one voltage level is 0 volt and the another voltage level is 5 volt. You can see this signal has two voltage levels, and 0 volt means 0 bit and 1 bit means 5 volt. So two devices should be following the same voltage levels. If the sender is considering 5 volt equal to 1 bit and receiver is considering 7 watt equal to 1 bit, then due to the mismatch of representation of bit, there could be problem in communication, right? The third is data rate. So there are different type of data rates available. There could be, the data rate can be 10 Mbps, it can be 100 Mbps, it can be Gbps. Okay, so it is a characteristic of physical layer. Then synchronization. Now what is the meaning of synchronization? As you can see in the figure, two devices are connected via a link. The data rate are different, means one device is sending data at 5 Mbps, but the receiver is receiving data at 2 Mbps. So when there is mismatch in data rates, there is possibility that data can be lost, because sender is sending data at 5 Mbps and receiver is not able to receive data at 5 Mbps. It can receive data at only 2 Mbps. So the remaining data will be lost. So synchronization means that two devices should be working on same frequency, on same data rate. Okay. Then transmission mode. There are three type of transmission mode: simplex, half duplex, and full duplex. What is the meaning of simplex? Simplex means one-way communication. Half duplex means that at a time one device can send or receive data, and full duplex means that two devices can send and receive data simultaneously. The example of full duplex is mobile communication. What is the example of half duplex? Walkie-talkie. And the example of simplex is your TV. Your TV receives data from television tower. It cannot send data to television tower. Then there is line configuration. There are two types of configuration: the point to point and point to multipoint. After that, there are different topologies are there. There is bus topology, ring topology, mesh topology, star topology, hybrid topology, etc. After that, the layer above the physical layer is called data link layer. Let's see responsibility of data link layer. There are four responsibilities of data link layer. The first is framing. Then there is physical addressing, flow control, and error control. Let's discuss all in detail. What is the meaning of framing? For example, when two devices are sending data, actually there will be stream of bits in link, and when there is stream of bits in link, receiver should know that what is the start of the data and what is the end of the data. So to do so, sender adds something extra data at the starting and the ending of the original data, so that receiver could know that from here it is the start of the data, and at this point it has to receive data, means it is the end of the data. So that is called framing. Then there is physical addressing. The physical addressing means MAC address. 48-bit MAC address are burnt on network interface card. You can see the first figure is the Wi-Fi card which can be found on your laptop, and the second figure is network interface card which can be found on your desktop. This network interface card or the Wi-Fi card has unique MAC address. So when the device is being manufactured, 48-bit MAC address is burnt on the device, and it is unique. From this address is unique, means that no two device can have same MAC address. The MAC address can be found in your device setting too. So you can check your phone, and in settings you can see that it has a unique MAC address. And there are total 2:48 MAC addresses available. MAC addresses are assigned by IEEE, and IEEE makes sure that no two device gets the same MAC address. Then the next responsibility is the flow control. What is the meaning of flow control? When two devices are connected and when two devices are having different rate, so there is possibility that data can be lost. So flow control means that sender will take care that receiver has received data or not. If the receiver is not received data, or the receiver is received data slowly, so sender will send data at very low rate. And the last responsibility is error control. Means when the device receives data, from data it will check that whether the received data has any error or not. If the received data has any error, then it can request the sender to send data again, or it can detect the error by its own and it can correct the error. Then there is the layer after the data link layer is called network layer. The responsibility of network layer is source to destination delivery, logical addressing, and routing. In the internet, there are many devices are connected, and when you send message from your device to your friend which is sitting far away from you, it is a responsibility of network layer to deliver that data. For that, it uses the logical addressing. Addressing in the network layer is also called as IP address. There are two types of IP address, IPv4 and IPv6. The length of the IPv4 is 32-bit and the length of the IPv6 is 128-bit. IP address is necessary if you want to connect your device to the internet. So when you purchase plan from your internet service provider, actually they are allocating you one IP address from the bunch of IP address they are having. This is the example of IPv4. You can see that it is represented by dotted decimal. What is meaning of dotted decimal? Dotted decimal means that numbers are represented in decimal and they are separated by dots. And the last responsibility of network layer is routing. There are two types of routing, static and dynamic routing. So what is meaning of routing? So when you are sending data to your friend, there are many devices which are between your device and your friend's device, and there are different paths available. So it is the responsibility of the network layer to select most efficient path so that data can be delivered to the destination very easily. Let's discuss the responsibility of transport layer. The transport layer has different responsibilities such as service point addressing, segmentation and reassembly, connection control, flow control and error control. Service point addressing is also known as port address. Port address is unique 16-bit address which is assigned by your operating system, and there are total 2 raised to 16 port addresses available. Segmentation and reassembly means that when the data is received from upper layer, the transport layer will divide that data into segments and it will number that segments. So because of these different segments will follow different route, the order will be changed at destination. So destination will see the number of these segments and it will arrange in the proper order. Then there is connection control, and after that the flow control. Flow control means that two devices are following different rate, so there is possibility that data can be lost. So sender will take care that receiver is receiving data or not. If receiver is not receiving data properly or it is receiving data at a very low rate, so sender will send data accordingly. This responsibility can be also seen in the data link layer. And last is error control, which can be also seen in data link layer 2. Then after that, the session layer, there are two responsibility of session layer, which is dialog control and synchronization. Dialog control means that you can enter into the session using dialog, you can establish the session, you can delete the session. Synchronization means that suppose you are downloading file which is large as 10 GB. Downloading is stopped at 7 GB. So when you retry to download that file, it will not start from all over again. It will continue from where it has stopped. So that is because of the session layer. It keeps track of all of your downloadings and it will resume from that. After that, there is presentation layer. The responsibility of the presentation layer is encryption, compression, and encryption means that it provides the SSL layer which is for security. Compression means that what type of files you are using, JPEG, MPEG, MP3, etc. And the last layer is application layer. The application layer enables user to communicate through the internet and it provides interface to the user. So this is it for the responsibility of the OSI layer. I hope you have learned so much new things. This is it. Thank you so much.